Welcome to this special episode of Frequency Matters, the RF and Microwave Update series. I'm Pat Hindle, and today I'm talking with Michael Glass, RF Systems Sales Engineer at Quantic Wenzel. Welcome, Michael.
Thank you for having me, Pat. I'm glad to be here.
Quantic Wenzel is an expert in ultra-low phase noise crystal oscillators, and they also produce like a wide range of advanced frequency sources and integrated assemblies. What are your customers looking for these days in low noise frequency sources, and especially when they're using them as clocks for digital systems?
Well, thank you for Pat for asking that question. Yeah, we're seeing a lot of activity. Obviously, in the industry, a lot of people are moving to digital based systems. Whether that's just ADCs, they're using them for the frequency source clocks for those, or whether they're using up converters like PLLs with integrated VCOs. Also, the more traditional DDS synthesizers, and then the newer chips like the RF SoCs and the direct RF systems. We're seeing an increasing use of these year over year. Products like the PLLs from Analog Devices or the RF SoCs from the AMD Xilinx chips or the Intel chips, the new Intel chips, they're requiring low phase noise frequency references as their sync and reference clocks. And as the design engineers are reviewing their system requirements, they're realizing that though these systems provide flexibility and reduced part count, that they continue to rely on a low noise frequency analog clock to produce the low noise floor. The source of like an OCXO is the one of the lowest frequency sources for low phase noise is available, and and included with an up converter in an analog domain, these frequency sources from 500 megahertz up to 3 or 4 gigahertz even can be used as the async clock to provide the best low noise floor. The newest generation of sync clocks do perform best when they use a low noise source like an OCXO with up conversion. And then the considerations for swap-C, for size, weight, and power and cost are weighed against the RF performance, and then also weighed against the environment, like harsh environments of high vibration and temperature ranges. And that's where we're seeing a lot of requests for new designs.
When you're talking with customers and engineers, what kind of new requests do you hear most often?
Well, so a lot of people are looking to keep the improved performance, even though they're preserving the low phase noise at the higher frequencies. It's becoming much more crucial as the designs of the digital systems improves. The noise floor of the frequency reference becomes just that much more critical, as that's the source generation of the frequency clock. We're also seeing improved requirements for close-in phase noise. So that's phase noise of less than the 1 kilohertz offset. And in radar applications, we're noticing that, which seems to point to the need to detect and track slow-moving UAS type targets for radar applications for both ground and ship-based systems as well. There are also some requirements for multiple output frequencies. For instance, signal generation of 100 megahertz, 500 megahertz, and 4 gigahertz all at one time, all being phase coherent, so they can be used together in a more complex system to track and lock ADCs and PLLs, and then the RF SoCs at the higher frequencies. And then we're also seeing a lot of ruggedization and vibration compensation examples for extreme environments. As everybody may or may not be aware, quartz crystals have what's known as a G sensitivity, and they will perform differently in different environments depending on the vibration levels. And so one of the things that Wenzel is looking to do is we're incorporating active compensation and passive compensation to actually reduce the sensitivity of the crystals in an active environment. And then finally, what we're doing is we're looking at customizations to meet the unique RF system requirements. For instance, if a customer needs maybe a lower frequency with a differential output, or they need a higher frequency at a very specific frequency for their RF SoC, we're seeing requirements anything from 2 gigahertz up to 4 gigahertz for the Xilinx chips. And then we're also seeing the higher frequencies where people are using the up conversion externally, and they're locking at 16 gigahertz or 32 gigahertz for chips like the Intel chipset.
So can you help us connect the dots? How do these new systems benefit from low noise frequency source for like radar and SATCOM performance?
Absolutely. So in the traditional method, the frequency reference basically sets your noise floor. And for applications like radar, for the noise floor resolution, and for SATCOM length with reliability, even a digital system relies on a frequency source, like an analog frequency source, in order to improve the close-in and the noise floor. And as the evolution of the RF systems move towards digital, the low frequency sources is still a key factor in delivering the high performance. And the OCXO technology with upconversion, like some of our products like the MXO product range, is still one of the best methods of creating these clock signals. And then finally, smaller form factors that incorporate ruggedization means that these platforms can carry the high performance frequency sources they need without sacrificing noise performance.
And so looking ahead, how is Wenzel positioned to meet the ever evolving needs and where can engineers learn more about these products?
Sure. So Wenzel can leverage our relationship with our sister companies. That's Crove Crystals and Microwave Dynamics for DRO frequency sources, which helps Wenzel to expand our capabilities. Our three teams in Austin, Whitby, Ontario, and Irvine, California, are taking these requests and we're delivering OCXOs, DROs, and integrated assemblies up to 50 gigahertz and beyond, with a pedigree in ultra-low phase noise, and in some cases as low as minus 190 per dBc per root hertz at the 100 megahertz output. Along with this and high frequency stability and rugged performance in a mission critical environment, the products that we're shipping are some of the highest qualities in the market. Since Wenzel was established in 1978, I can tell you that our team has consistently made RF engineers' jobs easier by enabling their systems perform at the most demanding levels. We'll hope that the listeners today can connect with us to discuss their unique RF and microwave system requirements. They can check us out on wenzel.com, quanticwenzel.com. They can research data sheets, technical research resources, and they can request a quote online, or they can reach us directly at sales@quanticwenzel.com.
Well, great. Thank you, Michael, for talking with me today about Quantic Wenzel's technology and your frequency sources. I have seen in the market you have some of the lowest noise sources around, so good job that everyone does there. So to our audience, you can find more videos at videos.microwavejournal.com. Thanks for watching.